Welcome to Algebra 1, Lesson 32 with Ms. Barrett. I hope everyone had a refreshing Memorial Day weekend and that you were able to ease your mind to get back to this distance learning and refocus. So today's lesson we're going to talk about, and we're going to review actually, graphing inequalities in slope-intercept form, and also graphing them in with two variable inequalities. So your homework is going to be the practice per usual. And the practice will consist of two problems that look exactly like the problems that we're going to do today. And then also some problems requiring you to plug in numbers. Okay, so when we talk about linear inequalities, so remember all linear functions can be written in the form y equals mx plus b. Okay. All linear functions can be written in the form y equals mx plus b. M represents the slope and b represents the y-intercept, or the point where the graph touches the y-axis. So m is the slope, rise over run, and b is the y-intercept. Okay. So when we have an equation, we can just graph the y-intercept and the slope. And that's what this would look like. Now, when we have an inequality, we have two types of inequalities. So we have a line, right, that you have to graph. And then we have to remember that inequalities have two things that regular equations of graphs of linear equations regular graphs of linear equations do not have. They have either a solid line or a dotted line, and they have shading. So when you graph inequalities, you have to have dotted or solid lines, and you have to have shading above or below. And we'll see what determines whether it's dotted or solid or above and below. So if you have a solid line indicates that the inequality is either going to be a greater than or equal to or a less than or equal to. So if the line is solid, it means that the solutions can be greater than, okay, or less than and equal to. So it means that it can be a number on the line. That equal to means that it can be, the solutions can be a number on this line. Now the shading will tell you whether it's greater than or less than. If you look at this line here, we can clearly see that the shading is below that line. That means that all of these solutions, all the solutions to this inequality are located in the shading, which is below this line. So that because the shading is below, we know that this is going to be a less than or equal to, because it makes sense. If the shading is below, then it's less than. It's like saying if the amount of money I have is below $20, then it has to be less than $20. Okay. Now, if you have a dotted line indicates a greater than or a less than. You notice that the difference between the two is that this has a greater than or equal to and a less than or equal to, and this has a greater than or less than. There's no equal to symbol. So the greater than and less than is denoted by a dotted line. And as you can see here, again, they have the shading below this line, so this would be a less than. It means that the solutions cannot be on the line. It would have to be anything less than where the line is. So it cannot be, if it's just a greater than or less than, it cannot be a solution on the line. Okay. And again, we just denoted that you have to have, for graphing an inequality, you have to have a dotted or solid line, and you have to have shading above or below. Now, how do you know when to shade above or below? You know by testing the point 0, 0. Always just test to point 0, 0. It makes life a lot easier for you. Test 0, 0 for shading. Always, just test 0, 0 for shading. I promise you, it makes your life a lot easier. So after you've graphed your line, you decided whether it's going to be dot or solid by looking at your linear inequality. You're then going to decide where to shade by testing the point 0, 0. Like this. So the question is 0, 0 a solution to the inequality y is greater than or equal to 4x minus 3? And all you have to do is plug it in. Plug it in. If I gave you the point 1, 2, if I gave you the point 5, 8, all you would do is plug it in to find out if it's a solution. So let's find out if 0, 0 is a solution to y is greater than or equal to 4x minus 3. I'm just going to plug in. Wherever I see x, I'm going to plug in 0. Whenever I see y, I'm going to plug in 0. Because remember, it's a coordinate pair. 0 represents x and 0 represents y. So it's going to be, instead of it being y is greater than or equal to, it's going to be 0 is greater than or equal to 4 times x, which is now 0, minus 3. Again, all I did was I plugged in my x and my y, which is 0 and 0. Wherever I saw y, I plugged in 0. Wherever I saw x, I plugged in 0. That's it. Now I'm going to solve it using my regular math skills. This is just 0 is greater than or equal to, now 4 times 0 is 0, minus 3 is negative 3. Question is, now we have to look at this inequality. Is 0 greater than or equal to negative 3? Well, yes. 0 is greater than. It's not equal to, but it's still greater than. So, yes, it is. So, this answer is yes. Because this is true, we say yes, 0, 0 is a solution to this inequality. Because it resulted in an inequality that was true. 0 is, in fact, greater than or equal to negative 3. Let's do another one. Now, next one says, is 0, 0 a solution to y is less than 2x minus 10? Again, we're going to take this coordinate pair, which represents an x and a y, and we're going to substitute 0 where we see y and where we see x. So this y is less than 2x minus 10 becomes 0 is less than 2x, and then x becomes 0. So 2 times 0 minus 10. Do our math. Okay, this is just 0 is less than 2 times 0 is 0 minus 10 is negative 10. The question is 0 less than negative 10? No. No, that's not true. That's false. So a false statement results in a no. That means that 0, 0 is not a solution. 0, 0 is not a solution to the inequality y is less than 2x minus 10. Whereas 0, 0 was a solution, yes, to y is greater than or equal to 4x minus 3. And we figure that out by plugging in 0, 0 into the inequality. Last but not least, is 0, 0 a solution to y is greater than negative 2x minus 35? All we're going to do is we're going to plug in x for 0 for x and 0 for y. So it becomes 0 is greater than negative 2 times 0 minus 35. Okay? That means that equals 0 is greater than negative 2 times 0 is just 0 minus 35. And you ask yourself, is 0 greater than negative 35? Why, yes, that's true. 0 is greater than that. So then, yes, the answer is yes. 0, 0 is a solution to this system. Okay? So there are going to be questions like this on your practice. It's just asking you, is this a point? It doesn't have to be 0, 0, but this is what we use to graph. Is a point a solution to a system? So you just have to plug the point in, not a system, an inequality. You just have to plug that point into that inequality and figure out if the answer is yes or no, based off of whether it results in a true statement or a false statement. Okay. Now let's get to graphing. Let's get to graphing. Now, if I if I give you an inequality, okay, you have to do a test, okay? You have to do a test. And what you're going to test is the point 0, 0, just like we just did, to figure out where you're going to shade. So if the test is a solution, so if 0, 0 is a solution, then you're going to shade on the side of the point 0, 0. So if 0, 0 is a solution, once you plug it into the inequality, then you're going to shade where the point 0, 0 is. If 0, 0 is not a solution, then you're going to shade on the other side. It's just that simple, and I'm going to show you in a moment. So if 0, 0 is a solution, you're going to shade on the side of 0, 0. If 0, 0 is not a solution, then you're going to shade on the other side. Let's do an example. Okay. So I give you a line. I say a linear inequality. I say graph y is greater than negative 2x plus 6. Okay. Y is greater than negative 2x plus 6. And remember, guys, when we're talking about inequalities, think about it as a mouth. This is the mouth of this symbol. So it's saying that y is greater than because the bigger part of the mouth is facing towards y. So that means that this is saying that y is bigger than negative 2x plus 6 because the small part of the inequality is facing negative 2x plus 6. Okay, so if I say y is greater than negative 2x plus 6, the first thing I need to do, step 1, is to graph the line. So we're going to identify our slope. Our slope here, m, is our slope. Our rise over our run is negative 2 over 1. Because remember, any number, any integer can be represented as a negative, that number over 1. Now our y-intercept, or where the graph crosses the y-axis, is 6. Our b is 6 because remember, it's y is whatever the inequality symbol is, mx plus b, where m is negative 2 and b is 6. So we need to graph that line. Always start with your y-intercept. And this is a review, guys. You learned this a long time ago. So I go to 6, which is right here, and I'm going to graph my point. That's my y-intercept. Then I'm going to go down 2 because it's negative 2. Remember, this is rise over run. And because it's a negative 2, it's not a rise. It's actually a go down. You go down. You don't rise because it's negative. So I'll go down 2, 1, 2. And then since it's the positive 1, I'm going to go to the right 1. And then I'm going to do that again from this point. I'm going to go down 2, 1, 2, into the right 1. Now, I usually only require 3 points, because once you get 3 points, you should be able to graph your line. I'm just going to do it one more time. I'm going to go down 2, 1, 2, because negative 2 is my rise. And then I'm going to go to run. Since it's positive 1, it's going to go to the right 1. Okay, now that I have the points, my second step is to make the line. So I have to draw the line. Remember, you're either going to have a dotted or solid line. Now, if it's a less than or greater than, it's going to be dotted. Just a less than or greater than, it's going to be dotted. If it's a less than or equal to or greater than or equal to, it's going to be a solid line. So for this inequality, we have a greater than, which means that the line is going to be solid. So I'm going to take my ruler and I'm just going to make my solid line. Okay. And I know it's solid because it's a greater than. Now, once we've graphed our line, we now have to decide where to shade. So we're going to use the point 0, 0 to figure out where we shade. Okay? Ladies and gentlemen, a correction here. Because this is a greater than, this is going to be a dotted line. Sorry about that. Miss Barrett makes mistakes too. So this line should be dotted. It's only solid if it's a greater than or equal to. So if it had that equal to sign, then it would be a solid line. So this line is dotted. So I'm going to rewrite my inequality. Y is greater than negative 2x plus 6. Okay. And I'm going to take the point. I'm testing the point 0, 0. This is my test. So wherever I see x, I'm going to put 0. Wherever I see y, I'm going to put 0. So it becomes 0 is greater than negative 2 times 0 plus 6. And I'm going to simplify that. 0 is greater than negative 2 times 0 is 0 plus 6 is 6. Now, is this a true statement? Is 0 greater than 6? No, that's false. So the answer to, is the point 0, 0 a solution? The answer is no. Okay, 0, 0 is not a solution. Therefore, since 0, 0 is not a solution, I'm going to shade on the other side of the point 0, 0. So here goes my graph. I have a solid line because it was a greater than. Here goes the point 0, 0. 0, 0 is not a solution. I know that because of my test. So I'm going to shade on the other side. Okay? Here goes 0, 0. It wasn't a solution. I know that because of my test. I'm going to shade on the other side. Okay? So remember, you have to have a line and shading. Your line is going to be dotted or solid. It was solid for this problem. And we figured out by our test where our shading goes. Let's do this again. Okay, I have now the linear inequality 8x minus 4y is greater than 24. Now, the issue with this one is we have one extra step. This problem is not in slope-intercept form. So I need to convert this to y is less than or greater than, or greater than mx plus b form. Okay. That requires me to do some work. So I want to get this y by itself. Okay. I want to get this y by itself. So the first step is to convert to slope-intercept form. So I want to go from here to here by getting y by itself. First thing I'm going to do is subtract this 8x. So always move the x term. Whatever the x term is, move that first. So I'm going to subtract the 8x on the left side. I must do it on the right side. That's going to give me, these cancel out. I'm left with negative 4y is greater than negative 8x plus 24. Okay, my y is still not by itself. Got to get that y by itself. So I have negative 4 times y. I'm going to divide by negative 4. Now remember, this is tricky. When you have an inequality and you multiply or divide by a negative number, you must flip the inequality symbol. So I divided by negative 4 on the left side. I'm going to divide everything by negative 4 on the right side. So that means my answer now, these cancel out. I'm left with y is now less than. I had to flip it. I had to flip it. You see this here? I had to flip it. Flip because divided by a negative. We have to remember that rule, so write that out. I had to flip it because I divided by a negative. So now it becomes y is less than, instead of greater than, it's less than negative 8x divided by negative 4 is positive 2x. And then 24 divided by negative 4 is negative 6. Okay, so instead of it being, we converted from standard form of an inequality to slope-intercept form by getting y by itself. So that's the first thing we did. But we had to remember that if you divide by a negative number, then you have to flip the inequality symbol. That's the case whenever you multiply or divide by a negative number. So now we have this linear inequality. This is our answer from converting. So that was number 1. We did that. Now we must graph the line. Here, my slope is 2 over 1, right? M right here, M is always with the x, so 2x, that means my slope is 2. And my y-intercept is negative 6. Take the sign with the number. So I'm going to go to negative 6 now. And we're graphing our line. We're doing step 2. I'll go to negative 6. And then since my slope is 2 over 1, I'm going to go up 2, 1, 2, to the right 1, because it's positive 1. Since positive 2 over positive 1, I'm going to go up 2 to the right 1. Then I'm going to do it again, up 2 to the right 1. And then for just a GP, I'm going to do it one more time, 1, 2, and to the right 1. Now that I've graphed my points and it's clear that they're aligned, I have to decide, is it a less than or equal to, or less than or equal to, or less than, or greater than or equal to, or greater than. Okay, because remember, if it's just greater than or less than, it's going to be a dotted line. If it's less than or equal to or greater than or equal to, it's going to be a solid line. And as we see here, it's just a less than, which means it's going to be a dotted line. So I take my ruler, and we can say dotted or dashed. It doesn't have to be just dotted, but you can do dash like this. Just take some space and make the dashes. See how that line is dashed? So I'm going to go ahead and draw my line. Now I have to do my test. I have to test the point 0, 0 by plugging it into this y is less than 2x minus 6. So I'm going to, wherever I see x, I'm going to plug in 0. Wherever I see y, I'm going to plug in 0. So I have now 0 is less than 2 times 0 minus 6. All I did was plugged it in and simplify. So 0 is less than 2 times 0 is 0 minus 6 is negative 6. Is 0 less than negative 6? No. No, that's a false statement. That's a false statement, right? Because 0 is greater than negative 6. So this is false. So no, 0, 0 is not a solution. So here goes the point 0, 0. I'm going to graph on the other side. Okay, I'm going to graph on the other side. Now, again, I'm sorry if you didn't see that, but all I did was plugged in that 0, 0 in here, and then it gave me this the inequality 0 is less than negative 6, which is false. So no, 0, 0 is not a solution. Here goes 0, 0. This is not a solution, so I'm going to shade on the other side. Now, what if 0, 0 was a solution? Then I would just say shade on the side of 0, 0, but it wasn't a solution for either one of these problems. All right, so the difference between the first problem and the second problem, okay, is that this problem was already in slope-intercept form. So I didn't have to convert it. Everything else is the same. The difference between this one and that one is that I had to convert it. This was standard form, I needed slope-intercept form. Okay, let's do another one. Now, this last one, we have negative 25 is less than 5x plus 5y. So this looks a lot like the problem we just had, where it's not in slope-intercept form. So the first thing we have to do is convert it. Okay? We have to convert it to y is, I guess, less than, it depends on what happens in between, mx plus b. So we need to get y by itself. Okay? So we're going to get y by itself by first getting rid of this x term. So it's 5x. So we're going to subtract 5x on the other side. It was positive, so we're going to subtract it on both sides. These cancel out. I'm left with negative 5x minus 25 is less than 5y. Again, y is not by itself. I need to get y by itself, so I'm going to divide by 5 on both sides. Now, I divided by a positive 5, which means that I do not have to flip this inequality symbol. You only flip it when you divide or multiply by a negative. So we're dividing by a positive number, no flips necessary. So this is going to give, I'm just going to write over here, this is going to give us y is greater than, okay, because these cancel out, negative 5x divided by 5 is negative 1x, and then negative 25 divided by 5 is negative 5. So y is, and I can move this around to be y is greater than negative 1x minus 5, okay? All I did was literally wrote the y in front. It's the same thing. See how it says y is greater, right? The arm is, the mouth is opening towards the y. That means y is greater. So when I flip it around, it's all still the same, as long as the mouth is open up towards the y. So now I'm going to take this inequality and I'm going to graph it. Take my slope. My slope m is negative 1 over 1, and my b, my y-intercept is negative 5. Okay. So I'm going to go to -5. Start there at my y-intercept. And then I'm going to go. So you can either go down 1 and to the right 1, but I don't have enough space. So if I go down 1 and to the right 1, that's fine. And I can go down 1 to the right 1 again. But what if I didn't have enough space? I can also go up and to the left. Up and to the left, okay? So I have enough points now. And I have to decide, is this going to be a dotted or solid line? Now, because this is just a greater than, then that means it's going to be a dotted line. Because it's not greater than or equal to. So I'm going to go ahead and dash my line. Okay, I'm going to go ahead and dash my line. And now I have to do my test to figure out where to shade. Okay, now I have to do my test to figure out where to shade. So I'm going to test my point 0, 0. Remember, just use 0, 0. This is my inequality. Y is greater than -1x minus 5. Wherever I see y and x, I'm going to plug in 0. 0 is greater than -1 times 0 minus 5. Simplify it. -1 times 0 is 0. Minus 5 is minus 5. So the question is 0 greater than -5? Yes. Okay, yes, this is a true statement. 0 is less than, 0 is greater than -5. So yes, 0, 0 is a solution. Okay. So now here goes the point 0, 0 on my graph. And we said it is a solution, which means that I'm going to shade on the side where 0, 0 is. Okay. I'm going to shade on the side where 0, 0 is. Okay, so now you've had 3 examples. Some a little bit difficult, some complex, some a little bit simple. Okay, your practice will consist of 2 problems like this that I asked you to graph it. And then there's going to be a few problems like this where I ask you, is 0, 0 a solution to this inequality? Okay. Hope everyone has a wonderful day and is able to go out and enjoy this weather. Bye.